Hello, I'm Martin Dent, Trent Water's Renewable Energy Development Manager. I'm stood here inside one of the large concrete silage clamps that we've installed at our crop digestion plant at Stoke Bardolph in Nottingham. Behind me you can see a wall of maize silage. This was harvested in October last year, and that wall is effectively 5.5 metres high. Within this concrete bay we can store about 7,500 tonnes, and we've got 4 other bays of a similar construction to this alongside. Each day we scoop up 100 tonnes of this maize silage and feed it into the front end of our crop digestion process. Our energy crop project at Stoke Bardolph is making a significant contribution to our renewable energy generation. Here in our reception at Stoke Bardolph Sewage Works, this display is actually showing how much power we're actually using to operate the plant and the various generating assets that we have here. We've got about 2.5 megawatts of combined heat and power plant running on sewage gas, but interestingly the crop digestion plant is also contributing 2 megawatts of production into the site. The net result of this is that we're currently generating 4.5 megawatts of power on the site, but only using 2.8 megawatts, so we're effectively exporting to the grid around about 1.7 megawatts, which we can use to offset our electricity imports from our other sites. On our sewage treatment works we use a traditional town gas holder to actually store the gas ready for use within the combined heat and power plants. Here on the crop digestion site we're using new technology, which are these butyl rubber membrane roofs that you can see behind me, the dome structures on top of the secondary digesters. So this is where the gas is collected and then it is fed through onto our combined heat and power plants for electricity production. Obviously building a plant of this particular type, the first and largest of its kind in the UK, take a huge amount of planning to ensure that we did it properly and we delivered the project on time with the right partners involved. We started the story around about 2007, where Severn Trent is farming 750 hectares of land around Stoke Bardolph Sewage Treatment Works. It's contaminated land because of historical waste recycling practices that have been done on the land. So there were limitations on what we could do. But we learnt of a new emerging technology across mainland Europe, where crops were being grown specifically for anaerobic digestion to produce electricity. The land here is suitable for growing maize, and we could grow around 37,000 tonnes of maize silage each year. After securing planning consent, we awarded the main contract to Interserve Project Services Limited, and we started construction of the site in June 2009. And in June 2010 we embarked on the commissioning of the plant, importing materials in to bring the anaerobic digestion process up to full scale. By October the plant was operating at full output, which was 2 months ahead of the original programme we had set ourselves. After we fed maize into the front loading bin at the front end of the process, a series of screw augers then actually feed the maize into the primary digester that you can see behind me. Obviously the maize is 32% dry matter, so it's quite a solid material, so we need to bring in some recirculation liquors from the back end of the process, which is rich in bacteria, to help kickstart the biological process and breakdown of the sugars and starches within the maize itself. So this process is heated to 40 degrees C and it stays within this primary digester for around 20 days. Biogas is given off, and that biogas is then collected in the dome of the secondary digester. After 20 days there's been sufficient breakdown of the maize material, the maize slurry, for it to go and be passed forward into the secondary digester, where it's held for a further 60 days so that we can liberate every last ounce of biogas out of that maize. That biogas is collected and fed through into our combined heat and power plants. Here we are in the technical room behind one of the primary digesters, and beside me here you can see part of the big electronic brain that is used to operate this plant. This HMI, human machine interface, has got every item of the plant labelled on it, and we can then go in and interrogate and look at each individual process that's happening and see exactly that the plant is operating as it's been designed to do. The biogas that's stored in the domes of the secondary digesters is fed in through the overhead gas pipework to feed these two 1 megawatt CHP containerised generating sets. These produce electricity at about 400 volts, and then through the switchgear and the transformers behind me, they go on to uprate the electricity to 11 kV, and then the electricity is exported across into the site ring main which feeds the sewage treatment works.
Hello, my name is Chris Brooks. I'm Water Business Manager for Interserve, and I'm responsible for our water technical treatment team. From the very outset, the need to work very closely with our suppliers, take a very intelligent approach, looking at key elements, key blocks of the delivery process was key to our success. So in conjunction with Severn Trent, in conjunction with key suppliers, it was essential we got everyone around the table, we got the design concluded, ironed out a lot of the technical issues that were going to face us later on if we didn't deal with them early. Having got to the point where the plant was now operational, it was absolutely key we focused on optimising the plant. And in conjunction with Schmack Biogas and Severn Trent, the team have continued to do that to the point we're now exceeding 2 megawatts of energy out of this plant. By taking this intelligent approach on this project meant ultimately we delivered this project 2 months ahead of programme, and obviously generating additional energy for Severn Trent to put back to the sewage treatment works and ultimately feed into the grid. Stoke Bardolph has been a fantastic project for us, really building on the strength we built up in our anaerobic digestion knowledge, skills and expertise. And going forward, waste to energy plants, food to energy plants, this really is a catalyst for us to build on and make sure we're a market leader in delivering such projects.
This project became totally operational by October 2010. And now it's fully operational. That's contributing 1.6% of the total electricity needs Severn Trent requires to provide its water and wastewater services to over 8 million customers living in central England and mid Wales. From my own personal perspective, it's been a fantastic project to be involved with. Successful delivery was key on getting the right partners together, and effectively for the teamwork and collaboration to bring the design and construction to fruition, to mean that we now have a flagship plant here, and one which I hope will be a catalyst for other similar projects elsewhere in the UK.